Welcome to example number 4. Here we're asked to find what the missing nuclei are in the following equations. So we have uranium-238. This is the parent that is decaying to thorium. So really, all you need to remember is just these two key principles: conservation of mass number and conservation of charge. So if you have a 234 here, what number must you add to that so it adds up to 238? Well, hopefully you'll realize that's 4. And on the bottom we have a 2, because 90 plus 2 gives you 92, and 234 plus 4 gives you 238. And then you have to look up this, and hopefully, or maybe you realize that this is really a helium nuclei, which is really a alpha particle. And hence, this first reaction is what we call alpha decay. Okay, moving on to the next one. We have carbon 14 that decays, and we have a -1 down here. That means that we have to have a 7 on the bottom, because 7 minus 1 gives you 6. And the top, it's going to be the same thing. So we now need to look up what the element is for 7 as the atomic number, or number of protons, and that's nitrogen. And by the way, this is a electron, or a beta minus particle. Okay, next one. We have cobalt that is decaying to Fe, which is iron. And we see that the number of top is not changing, so this is just a 0. But on the bottom, we have 26, so we have to have 1 on the bottom here. So you have 26 plus 1 gives you 27. And this is a positively charged electron, which we call a positron. So in this case, we have a situation of beta positive decay. The last one was beta minus decay. Okay, moving on to D. This symbol here is, you may not realize that is the alpha symbol, which stands for an alpha particle. So you have to realize that this alpha symbol is an alpha particle, which is really a helium nuclei. So you have 206 and 4. That gives you 210 on the top. And then you have 82 and 2. That gives you 84. And the element that corresponds to 84 is PO, polonium. And this is another example of alpha decay. Alright, over here we have nickel with a little asterisk. Remember, an asterisk means that it was in an excited state, and then it goes back down to its regular state. So now, what is being emitted? Just have to simply put the symbol gamma, because that's a photon, a high energy gamma ray photon. Now, this is an example of gamma decay. The last one, this is like a nuclear reaction. A neutron bombards this boron nuclei. And if we look at it, we see an alpha particle is emitted. And we have to have on the bottom a 3, because we need to make sure that these two numbers add up to 5. Because 5 plus 0 is 5, and 3 plus 2 is 5 here. And then on the top we have a 4, and then over here there's 11. So this must be a 7. And the element that corresponds to 3 as the atomic number is lithium. Alright, and that's it for example 4.